Uh, in the last lecture, we ended by talking about the fork join, the way that basically threads have fork and join and how fork and join works. We had actually during the last lecture even played a bit with fork. Today we're going to talk into more details about how thread actually is implemented in most operating systems. So first of all, a thread has what is called thread control block. And the thread control block is basically something very similar to the process control block that we learned about earlier, the PCB. It's basically a data structure that stores all the states of the performance computation. So if you're running a long program, what line are you in, and so on and so forth. So it basically stores also, for example, your variables, your thread variables. It stores data that is required for the management of the thread. So for thread scheduling, which we'll talk about into much more details pretty soon, as in I think 1 or 2 lectures from now. It helps in these things. It stores data that is required by these for scheduling, basically. Then you have the stack information also stored, and it stores what functions or methods are running in the thread, because the thread is basically a program, so it can have multiple functions, multiple methods, multiple procedures, depending on what application you're actually running, right? So, and depending on the programming language you have been using also. Whenever a new thread is started, you basically allocate some part of the memory in a very similar way to the PCB. You basically have a heap and stack for each per thread, and that is basically used for the thread to function, to do what it is supposed to do. And of course, all of these, the pointers to these are stored in the TCB, just like the case with the process control blocks. So, I have a question here. Do you think that we can have one single stack for all threads? Can we basically just have a single stack for all the threads if you have 1,000 threads running on your computer that are doing different things? Is it wise to have a single stack for all of them? Okay, so the PCB basically also, when a thread gets suspended or evicted because of an hardware interrupt, for example, because it has already been running for a long period of time or something like that, you save the registers of your thread in your TCB, your thread control block. You save the state of the processor, registers such as which part of the instructions are you in, the instruction pointers, and so on. The actual implementation is very operating system specific. It also depends quite a bit on the actual hardware that you're running on. What your choice basically your design decision is influenced by both your hardware and the whole operating system in general. And the way you implement the TCB is also different in different operating systems, of course. You either have the saved registers as part of the stack or have a separate space in the TCB for this. So you basically, when storing the saved registers after being evicted, you have a choice to basically have it either in the thread stack, stored in the thread stack, which is basically a chunk of memory that's allocated to the thread, or on the TCB, which basically stores all data that the thread needs. There is, of course, per thread metadata also that you have on your TCB, such as your thread ID. So you can have, it's equivalent to the PID, which we have been looking at for the processes, for example. You can have different scheduling priorities, and you can basically have a thread that is waiting for some input or ready to run later. You can have threads also with shared states. So basically, if you have 100 threads that all run the same program, which is, let us give an example with the web server. I mean, if you have an Apache web server, basically the handler for each request is roughly the same. I mean, you're running basically some, I mean, it can be, of course, anything that is beside worldwide HTTP, but I mean, you have some sort of server that handles incoming requests from different clients. And these requests can be FTPs, can be HTTPs, or something, depending on basically the software that is running on the server. But for an Apache web server, you basically have something that will replies for a get with some, you have some procedure to do a get, some procedure to do a post, and so on. So you are sort of running the exact same code for each request that you receive. And that's basically shared state. So that program code is one of the shared state. But also you can have global variables, like in any programming language, you can specify some variables to be global. They become very hard to manage when you're talking about concurrency, about threads, because basically if you have global variables that are being changed by multiple threads at the same time, you want some way to basically make sure that there is consistency when changing the variables. Okay. Now, what space is a normal thread running in? It's usually running in the user space. There are kernel threads that we'll talk about in more details. The question is also if a thread can corrupt the data of another thread, and again, this is highly dependent on how you implement things. So if you have multiple threads having shared states, then you need some locking mechanism on that. We'll talk about that in the next lecture, actually, synchronization mechanisms. But also, I mean, you are not supposed to be able to touch other threads that do not share state with you. Their memory, for example, you're not supposed to touch their data.